after much thought, because your boss keeps apparently changing how much you get paid. After much thought, your boss has finally decided on permanent employee wages, which are randomly assigned using probability distribution X given below. Additionally, at the end of the year, she'll give an employee an hourly raise. The pay raises are assigned randomly according to the probability distribution Y given below. Assume X and Y are independent. Okay? So go ahead and go into your calculator, type this cute little table in, tell me what the mean is, tell me what the standard deviation is. And we learned what variance was yesterday. How do we find variance?
Multiplied by squared.
Variance is our standard deviation squared. That's supposed to be a sigma. It's not happening. This is getting worse. Okay, so go ahead and type that into your calculator. If you don't remember, go to your how-to calculator sheet. You're typing it in, find your mean, standard deviation, and the variance, which is sigma squared. Take a second. All right, so remember, we only have 2.5 minutes per question, right? So you gotta type fast. Okay, so find the mean. What'd you get? 11.85, great. Standard deviation? 2.22, variance. And I think, honestly, on that list of things, if you scroll down, variance should be like down at the bottom. It's sigma squared. So it should be like 4.93. 4.93. Yeah. With variance, make sure that you don't round your standard deviation when you square it, because it does change like that second decimal. Okay. You're going to try the same thing, but with the next table. Yay. So find the mean and the standard deviation and the variance. I need you to practice typing this in. Great. So when you find the mean, standard deviation, and variance for this one, what'd you get? Mean? 1.6.
1.6.
Okay. Standard deviation?
0.1. 0.9192.
Okay. 0.92. And then variance should be about 0.84. Yeah. Questions? Everybody can do that in their calculator. Okay. All right. So what are the possible, let in the new hourly wage for the upcoming year be X plus Y. Okay. So what are all the possible new hourly wages for the new year? So X plus Y. So what's 9 plus 1? 10. What's 12 plus 1? Okay. I don't know why this thing is not thinking. So 10, 13. What is 15 plus 1? Okay. Do we understand where I'm getting these numbers from? We're taking the numbers for X and then adding them to all possible values of Y. Okay. So we're going to take 9 plus 3, which is 12. 12 plus 3, which is 15. And then 15 plus 3, which is 18. So you should have 10, 12, 13, 15, 16, and 18. Good? Now, what is the probability of getting a $9 wage and a $1 raise? Okay, so what is the probability? When we write this out, we always want to put it in like the little notation. Probability of X equals 9 and Y equals 1. Okay, point 21. And how do we get there? Well, the first one, probability of getting a 9.
0.16 into infinity. Yeah, that's probability or 1.
So probability of X equals 9 is 0.3. And then we're going to multiply it by 0.7 because that's going to be the probability of Y equaling 1. So that should give you 0.21.
Thank you.
Can you try part C? Make sure you write the notation.
Oh, yeah, now that's what I'm not equal, not uniform, so like. Yeah, I could do this this time.
So the probability of getting 9 is what?
0.03.
0.3. And then the probability of y being 3 is
Times 3.
times 0.3,
Times what times.
which is going to give us 0.09.
Yeah.
So when it asks you to show your work, that's
Yeah,
what you're doing.
I'll do it. Wait a minute.
Now remember, they told us that x and y are independent. X and y are independent. All right, so now you're going to fill in the table below. Remember, n is the new numbers. So that list that we made in part 3A, we're going to list that across the top, and then you're finding the probability for each one. Yeah? Okay, so like the first one would be 10, and we found that probability in part 3B, which is 0.21. Can you find the rest of them? So for my visual people, you're filling in this table, and you're going to put 10, 12, 13, 15, 16, 18. And then we found the probability of getting 10 as 0.21. Can you find the probabilities of the others?
Yay.
All right, take a second, fill that table. All right, so when you did that, you should have gotten 0.09 for 12, 0.315 for 13, 0.135 for 15, 0.175 for 16, and 0.075 for 18. Everybody get how I got those numbers? No. Okay, go ahead. Okay, so like we did on part 3A, you see how it says, what's the probability of getting a $9 wage and a $1 wage with raised? That probability that we found is what went down here for 10. So if we were trying to find 16, well, if we look back up here, 16 would be the combination of 15 and 1, right? We would multiply those two together to get 16. Does everybody see it? Okay. I'm going to put those numbers back up here so that you're good. Go back. Cool. All right. Now that you have this table, find your mean, standard deviation, and variance. Okay. Again, practice typing that in. As you're, it's okay. As you're putting them in and you run the stat one variable test, okay, remember, change your frequency, okay, and then check your answer. So your mean should be 13.45. Yes, no, maybe.
I have no idea. I'm so typing.
Okay. All right, 2.4 for the standard deviation, and then 5.77 for the variance. Did you get that, or did you? Okay, cool. All right. Now, for n equals x plus y, we're going to write the formulas for the following in terms of x and y. Okay, so the mean of it would be the mean of x plus the mean of y. So back up at the top, we would add the two means that we got at the top. So that's 11.85 plus 1.60. You see those two numbers up at the top, right? Okay. For standard deviation, okay, you're going to take the square root of the standard deviation of x squared plus the standard deviation of y squared. And then the variances, you're just going to add the variances together. So instead of like plugging all that mess in, we already found the mean standard deviation for both tables. Okay. Everybody okay?
Still typing. I'm trying to write it down, still typing.
So just a summary on that. Your variances you're going to add, your mean you're going to add. For the standard deviation, you have to turn it into your variance first, add them together, and then take the square root. Okay? Cool?
No.
Yep. All right. Go ahead and go to the next page once you're done. Go ahead and do your check your understanding, and then I'll give you the little summary in just a second, but go ahead and start on that check your understanding first. Okay? You're calculating and interpreting mu sub b. What does this actually mean? Like, what are they trying to find? Why are they doing x minus y?
Why not?
Because what is x? Okay, so this graph right here is x. This is y, right? So we're finding the difference between these two. So did the home team have more points than the away team? Yeah. So when we calculate, all right, so we're going to calculate by finding the mean of both of these, which they already gave us. So we're going to take 22.98 and subtract 20.90. Everybody see where I got those numbers from? It lists up at the top. Okay, that's going to give me 2.08. Now here's the important part, because this is always your FRQ. If we interpret, that means that if we were to choose many NFL games, the average difference in points for home versus away is 2.08 points. Everybody good on those? Okay. All right, so on the next part, it's asking us to calculate and interpret the standard deviation. So you use those formulas from earlier, right? And so this one is going to be to find the standard deviation of D. That's going to be the standard deviation for the first one squared plus the standard deviation of the second one squared. And then we're going to take the square root of that, which is going to give us 13.23. Do we see it? I understand. Go ahead. What's the formula for standard deviation? Look back at previous page.
Where says N?
No, the calculation is the standard deviation. You're not subtracting, because that would be, I don't want to describe this. That would be where they cross over instead of actually calculating this new standard deviation. Yeah. No, she's not happy with that answer. For the last one on the front page, how we found the mean was n plus y, right? That was the formula they gave us because they wanted us to combine it because we were adding those two things together. This one, they're asking for the difference. Your formula for standard deviation is not going to change based off of if you're adding or subtracting. It's the same every single time. Does that make sense?
Yeah.
Okay. Okay. C is where we got a little crazy. Yeah. Okay. So suppose we randomly choose a game and record the number of points from the home team, and then independently randomly chose another game and record the points from the away team. What is the probability that the home team has more points? Okay, so what is the mean? 2.08, right? We want the home team to have more points. So if we were going to find the difference between the home team and the away team, is it going to give me a positive value if the home team has more points or a negative value? A positive. But anything greater than 0 would give me that result. So what are we going to do here? We're going to calculate the z-score. So 0 minus 2.08 divided by the standard deviation. And that's going to give me negative 0.16. We're going to go into our table, going to find the corresponding number, and then we're going to do 1 minus that number. And that should give us an area. God bless, man.
God bless America.
This is not right. This will give us an area of 0.5625. Yep. Because anything greater than 0 would give us a positive number, which would mean that the home team would make more points than the away team. Yeah? Did that help? You said it did make sense or it does make sense?
Yeah.
Oh, okay, cool. It'd be like that. Flip the page. We get to talk about the World Cup. Hey! Oh my God. Did y'all see the, hold on, let me mute myself. So the standard deviation does not change. This is combining random variables. This is, hey, we're going to put these two things together, or hey, we're going to find the difference between these two. Okay, so take a moment, go ahead and write that down. Okay, so the U.S. women's soccer team is doing some calculations to help prepare for the upcoming World Cup. They are convinced that the toughest matches are likely to end in a tie. These matches require a shootout to break the tie, where each team gets 5 penalty kicks. They believe that they'll need to make 4 or more penalty kicks to win. Okay, we are talking about binomial random variable. On your paper, I want you to write binomial random.
Where?
Up at the top.
Where? I wrote a
Anna.
B instead of a B. Why?
You gotta stop, baby. All right, so go ahead and write that down. So over the history of the World Cup, about 70% of the penalty kicks in a shootout are made. Let's assume that the probability for each of the players of the U.S. team and that each kick is independent. This is really important, that each trial is independent. Okay? So our p-value is going to be 0.7. How many fixed trials do we have? Fixed trials is going to be 5. You got 5 opportunities. Fixed trials is n equals 5. Okay, this section uses a lot of variables, so hang with me. So n is 5, p is 0.7. All right, so let's look at, will they make all 5 penalty kicks? So probability of making all, which means that it's the probability of making the first and making the second and making the third and making the fourth and making the fifth. Okay, so that's going to be 0.7 times 0.7 times 0.7 times 0.7 times 0.7, which is 0.7 raised to the 5th power. Somebody type that in the calculator. Okay, so 0.168.
Okay.
About 17%. Yeah. Now, what's the probability that the team will make exactly 4 of the penalty kicks? So that means that they're going to make all 4 and then miss the 5th one. Okay, so that's going to be 0.7, 0.7, 0.7, 0.7, 0.3. Why am I doing 0.3 instead? Because they're missing it, right? Okay, so down at the bottom, we've got 0.7 raised to the 4th power and 0.3 raised to the 1st power. When we multiply that out, you should get 0.072. So there's about 7% chance of that happening.
Wait. Yeah. Okay, almost there. Oh, wait. Oh, wait, I put it in the wrong, put the answer in the wrong line. There we go. Fix it.
Okay, good.
Yes.
Name another way to make exactly 4 penalty kicks. So what's another way? Okay, miss the first and then make all the rest of them.
Yeah.
Run out of room. Okay, so that's going to be 0.3, then 0.7, 0.7, 0.7, 0.7. 0.3 raised to the first, 0.7 raised to the fourth, and that's going to be 0.072. What do you notice about the probabilities in part A and part B? They're the same. It's not a trick question.
Yay. That's good.
How many different ways are there of making exactly 4 of the penalty kicks? So let's list them out. We've done a couple of these. We're going to use check marks and X's to help us. So if we make all 4 and then miss the last one, or if we make the first 3, miss the fourth, make the last one. Or if we make the first 2, miss the third one, make the last 2. If we make the first one, miss the second one, and make the last 3, or if we miss the first one and then make all the rest. Is that all the different ways?
Okay. Oh.
So how many ways are there?
5.
5 ways.
Oh my God. Sorry.
Okay, throw back to algebra 2/accelerated geometry. You have 5 ways, and you're gonna choose 4 of those to make, right? Like we had 5 fixed trials, but we need 4 of those to be good, right? In order for us to make it. Okay. So oftentimes you'll see this as NCR. That red.
Yeah, I see.
Overall, what is the probability that the team will score on exactly 4 of the penalty kicks? So this will be 0.072 plus 0.072 plus 0.072 plus 0.072 plus 0.072. Why am I adding all of those up? Well, those are all of our different ways. Those check marks are all of our different ways that we can make 4 penalty kicks, and they all have the same probability. So we have the opportunity to make any single one of them, which is going to be equal to 0.36. One student calculated the probability of making exactly 4 of the penalty kicks using this formula. Identify what each part of the formula represents. So what is this 5 out front? Number of ways. Number of ways. How many ways did we have? 5. Okay. What about the 0.7 of probability of success? What's 0.3? Probability of failure. It's always my favorite word in stat. And then the 4 is the number of makes, and the 1 is the number of misses. Okay. So X represents the number of penalty kicks made, right? So this formula right here is represented by this, okay? This is the stat way to write it. Probability of X equals 4 is equal to 5C4, or the way I read this is 5 choose 4. 5 opportunities, you're choosing 4 to make it, okay? Times 0.7 raised to the 4th power times 0.3 raised to the 1st. I'll give you a second to catch up. All right, so if a World Cup game ends in a shootout, what is the probability that the U.S. team wins? That means that they need to make at least 4, right? So let's take a look. We need at least 4. That means probability of X is greater than or equal to 4. What's the probability of them making 4? Well, we just found that, right? That's 0.36. We have all those different ways to do it. What's the probability of making 5? 0.168. We're going to take both of those probabilities and add them together. And that's going to give me a probability of 0.528. What's the probability that the U.S. team wins? 528. USA. No. Okay. Thanks, guys. All right. Flip the page. Yay! We're almost done. Okay. So binomial random variable. When you are asked to describe how this is a binomial random variable, this is what you're going to write down. Okay. There's a little acronym for you to remember. Do you remember how we did like SOC for describing the distribution? For this one, we have BINS. B-I-N-S. B is going to stand for binary. So either it has a success or a failure. Okay, I is going to stand for independent trials. So the trial before has nothing to do with the next one. N is the number of trials is fixed. So for instance, if they have a shootout, then they can't have like an indefinite amount of kicks. They could only have a fixed number, which they only have 5 attempts, right? And S is the same probability of success. So the binomial formula, we just wrote this down. Don't stress out about all these variables, okay? So P probability of X equals K is equal to N choose K times the probability of successes times the probability of failure, which is N minus K, times. Yep, lots of variables. P is the probability of success. K is the number of successes. N minus K is the number of failures. Okay, so it's just like what we wrote down earlier. So this is success. This is failure.
Oh wait, I'm sorry, I need to erase this.
This is the probability of failure. Probability of success. This is the number of ways to get success. I know that one's really tough. I got it. Okay. first thing. How do we know that this is a binomial? Like, how is it binary?
Because it's binary code. The binary code.
You can hit the most, or you can just not.
Right. You can succeed or you can fail.
Yep.
Like, that's it. So on your paper, when you do these, I would list out bins, like literally type it out. So B is binary. So each trial is, each try is either whack-a-mole, which is a success, or miss, which is a failure. Okay. Each time you try, it's not impacted by the previous one, theoretically, right? We're excluding feelings on this. Like, you're not going to get mad. Oh my God, I didn't hit it, So each try is not affected by the previous mole. Okay. Number of trials is fixed. How many trials do we have? So n equals 20. And same probability of success for each trial, which is P equals 0.8. Good? That is an FRQ on your test. That's part of it. Yeah? Good? Okay, on part B, it says next you play skee ball. You know that you have a 10% probability of getting any given ball in the 100-point hole, but Y represent the number of balls you must roll until you get one in the 100-point hole. Is that binomial? No, why? Not a fixed number of trials.
Yep.
Okay, so on part B, not a fixed number of trials. Everybody good on part A and B? Okay, number 2. Now you play a game called Tsunami Duck Pond. That sounds like an awesome game. Okay, let W equal the number of times you win if you play this game 10 times. W is a binomial random variable. Identify the fixed number of trials and the probability of success for each trial. Okay, so when you do this one, how many times, what is N going to be? Huh? 10. And the probability is 20 out of 100, which is 0.2. So we see how we got that. Okay. Find the probability that you win exactly 3 times. The probability of W equals 3 is equal to 10 choose 3 times 0.2 raised to the 3rd power times 0.8 raised to the 7th power. This is probably where you stopped, right? Okay. On your
Z or a 7 or a 2. That's 2.
This is a 7. This is 0.2.
Okay.
So on this one, you can, in your calculator, do the NCR. So I don't expect you to sit there and calculate how many different ways you can get this to happen. Yeah. So if you go into your calculator and you go to calculate, okay.
I know how to calculate. Wake up. Thank you. It's already in calculate mode.
You go to menu,
Menu.
probability,
Probability.
combinations, and the NCR types or pops up. Okay. So you're going to put 10, I think it's comma 3.
Okay.
10 comma 3.
10.
Okay, so again, you go to menu, stats, probability, 10 comma 3. You should get what number? 120. So now this number is 120, and you're going to multiply it by 0.2 raised to the 3rd power and 0.8 raised to the 7th power.
That's 120.
Mm-hmm. And so when you do that, you should get a probability of 0.2013.
120. Oh, wait. Oh, thank you. Everybody good? Almost there.
Okay.
Okay, now we can move on.